In this video, we will explore the concepts of disk management, focusing on disk structure, formatting, and bad block management. Understanding these aspects is crucial for efficient and reliable data storage. Let's begin by understanding the structure of a disk. A disk consists of platters, which are circular disks coated with magnetic material. Each platter is divided into tracks, which are concentric circles. Further, each track is segmented into sectors, which are arc-shaped sections. A cylinder refers to the same track position across all platters in a multi-platter disk. And finally, clusters are logical groupings of sectors used by the operating system to manage files. Now let's discuss disk geometry and addressing. There are two main ways to address data on a disk. The first is physical addressing, which uses cylinder, head, and sector or SSDs coordinates. The address is represented as cylinder, head, and sector. The second is logical block addressing or LBA. Modern systems use sequential numbering to address blocks. The LBA is calculated as cylinder times heads per cylinder plus head, all multiplied by sectors per track, plus sector minus 1. Here, HPC stands for heads per cylinder and SPT stands for sectors per track. Next, we will examine disk formatting. Disk formatting is the process of preparing a storage device for use by an operating system. There are two primary types of formatting: low-level formatting and high-level formatting. Let's explore each in detail. Low-level formatting is the process that organizes the disk surface into tracks and sectors. It creates sector identification information, generates gap areas between sectors, and implements error correction codes or ECC. It also maps out any known bad sectors, marking them as unusable. This type of formatting is often performed by the manufacturer. A sector typically includes an ID field containing cylinder, head, and sector numbers, a data field, which stores the actual data and can range from 512 to 4096 bytes, and an ECC field for error detection and correction. High-level formatting, on the other hand, creates file system structures on the disk. It writes a boot sector with bootstrap code, initializes file allocation tables, and creates an empty root directory. High-level formatting is typically performed by operating system commands such as format or mkfs. Common file systems include FAT32, NTFS, and exFAT for Windows, extension 4, XFS, and BTRFS for Linux, and APFS and HFS Plus for Mac OS. Now let's delve into bad block management, which is the strategy for handling defective sectors on a disk. Bad blocks can occur due to manufacturing defects known as hard errors or develop over time, referred to as soft errors. Other causes include surface degradation, physical damage, and magnetic field interference. Detection methods involve read or write verification tests, error correction code failures, self-monitoring analysis and reporting technology or S.M.A.R.T, disk scanning utilities, and automatic detection during input-output operations. There are several techniques to manage bad blocks. Sector sparing or remapping redirects input-output from bad sectors to reserved good sectors, maintaining a defect map to track remap sectors. Sector slipping skips bad sectors and shifts all subsequent sectors, preserving sequential logical addressing. Another method is maintaining a bad block table, which lists known bad blocks, and the file system avoids allocating these blocks. Finally, let's explore modern approaches to disk management. RAID systems, or redundant array of independent disks, provide data redundancy, improve performance, and tolerate disk failures. S.M.A.R.T technology, or self-monitoring analysis and reporting technology, predicts disk failures by monitoring disk health metrics and provides early warnings. SSD management involves leveling algorithms, trim command support, bad block management, and over-provisioning to optimize solid-state drive performance and lifespan. Modern disk management combines hardware techniques, firmware solutions, and operating system support to ensure data integrity, maximize performance, and extend disk lifespan. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.